Two programs ask the same website for the same page at the same second. One gets the data and moves on. The other gets a captcha, then a soft block, then nothing at all. The request they sent looked almost identical. The difference was decided before either of them finished saying hello, by a stack of checks that most people who write scrapers never actually see. Today I want to walk you through that stack from the outside, the way the site sees it, and then show you what a scraper that plays by the rules does differently, because that is the version that actually keeps running. I run proxy infrastructure and production scrapers for a living. Real farms, real pipelines, the kind that pull public data at scale every day and have to keep working for months without becoming somebody else's incident. So I have spent a lot of time on both sides of this wall, watching how sites decide who is a person and who is a machine, and building collection that stays on the right side of that line. I am not going to teach you how to sneak past anything. I am going to explain how the detection works and how a compliant operation stays clean, because honestly that is the only version worth building. What the site is actually asking. Start with the question the site is really trying to answer, because it is not the one most people assume. A modern platform is not asking, is this a human or a bot? Plenty of bots are welcome. Search crawlers, uptime monitors, link previewers, and the site waves those through on purpose. The real question is narrower. Is this traffic behaving the way it claims to? And do its own signals agree with each other? Detection is a hunt for contradictions. Every check I am about to describe is one more place where an automated client can accidentally say two different things at once and get noticed for the mismatch. The network you arrive on. The first thing a site sees is where you came from, and that lands before you send a single byte of a real request. Every connection arrives from an IP address, and every IP sits inside a larger block that belongs to a network, identified by a number called an ASN. There is a whole industry that labels those blocks. This range is a mobile carrier. This one is home broadband. This one is a hosting company's data center. Sites buy those labels and cache them right at the edge, so the classification is basically free and it fires on the very first packet. A request from a residential or mobile network starts with ordinary trust. A request from a cheap data center range starts under suspicion, because historically that is where the automation has come from. There the statistics are not usually about you, it is about your neighbors. A fresh data center IP, with no history of its own, still inherits the code reception of every scraper that ever ran from that provider. This is why pointing the cheapest pool of server apps at a strict site tends to fail almost immediately. It is not that anyone caught you doing something wrong. It is that the network you rode in on was already wearing the wrong label before you ever arrived, and the label is doing the deciding. The handshake before the page. Before any page loads, your client and the server set up an encrypted channel, and that setup is surprisingly loud. The exact way your software negotiates TLS, the cipher options it offers, the order it lists them in, the extensions it includes, all of it forms a pattern. Real browsers produce well-known patterns here, and they shift in predictable ways as the browsers update. A lot of scraping tools produce a TLS pattern that no real browser would ever send, because the underlying HTTP library was never trying to imitate one. So a client can claim in its headers to be a current version of Chrome, while its handshake quietly says, I am a generic HTTP library. That is a contradiction, and the edge is built to catch exactly that kind of mismatch. The headers you send, once the channel is open, the request itself carries more tails. A real browser sends a specific set of headers, in a specific order, with a user agent string that agrees with the rest of the set. The field a site reads as your user agent is just text, so anyone can type Chrome into it, but the rest of the request has to back that claim up. Real Chrome sends particular hints about the platform, the language, and the way it handles compression and connections. An HTTP client that sets a browser user agent and then forgets the dozen other things a browser would send is telling two stories again. Detection here is mostly consistency checking. Do all the parts of this request describe the same thing they say they are? What the browser reveals. When a site wants a harder look, it runs code inside the browser itself, and this is where headless automation gets tested. A normal browser driving a real screen exposes thousands of little properties. The size of the window, the fonts installed, the way the GPU draws a shape onto a hidden canvas, the exact features web GUI reports, the timing of small operations. Real devices vary across all of that in messy, natural ways. An automation setup that spins up the same headless browser again and again tends to produce the same fingerprint every time, or a fingerprint carrying tells that a normal machine would never have. The site is not hunting for one magic value. It is looking at the whole shape and asking whether it resembles a real person's device or a cloned machine sitting in a data center. There is one more layer that sits between allow and block, and most people have brushed against it without knowing what it was. When a site is unsure, it does not always decide right away. It hands your client a small test, a bit of work a real browser does without thinking, and watches whether you can complete it. For a person on an ordinary browser, this usually passes invisibly, a half-second pause they never even notice. For a crude automated client, the same test is a wall, because it cannot do the thing a real browser does. That occasional "please wait a moment" screen is this layer running, quietly deciding whether the thing knocking behaves like a real browser or only claims to. How fast and how evenly you move. Past the technical fingerprints, sites watch behavior, and behavior is where scale betrays automation. A person browses in bursts, pauses, gets distracted, moves in sloppy curves, reads for a while, comes back. A naive scraper pulls pages at a steady machine rhythm, one after another, faster than a human could read, at perfectly even intervals, around the clock with no sleep. None of those individual requests is strange on its own. It is the shape over time that stands out. The site is comparing your rhythm to millions of real sessions, and a flat, tireless, evenly spaced pattern simply does not look like any of them. The patterns across the whole crowd, and it widens out from a single connection to the entire crowd. Edge networks sit in front of a huge slice of the web, so they see traffic for countless sites at once. That lets them spot a swarm of fresh visitors, all taking the same path through a site at the same speed, or many separate IPs that each look fine alone but move in lockstep. Rate is part of it, how much you pull and how quickly, but pattern is the deeper signal. One address that earned a bad reputation somewhere else an hour ago arrives already suspect. A new automation pattern caught on one site becomes a signature that defends all the others within minutes. The defender gets to watch everyone at once, and that view is very hard to beat. Fun. How a compliance scraper stays clean. So what does an operation that respects the rules actually do differently? It starts by reading the robot's file and honoring it, treating the parts a site asks you to leave alone as off-limits rather than as a suggestion. It identifies itself honestly where a site expects that. Instead of dressing a server up as a browser, it is not. It collects public data only, and stays away from anything behind a login, a paywall, or personal information that was never meant to be harvested. The goal is not to look human when you are not. The goal is to be a well-behaved automated client that a site has no real reason to block in the first place. Respecting the pace is the strategy. The biggest lever is pace, and it is the one people skip because it feels slow. A compliance scraper runs at a rate the site can absorb, spaces its request, backs off the moment it sees errors or slowdowns, and caches aggressively so it never asks twice for something it already has. It prefers an official API when one exists, because then is the front door the site actually built for you. It keeps the load light enough that a human running the site would never notice it was there. Done this way, most of the detection stack I just described never even has a reason to fire, because you are not producing the contradictions it hunts for. You are just a small, steady, polite stream of requests for public pages. When in doubt, ask first, and there is a step that sits above all of the tooling, which is simply to ask if a site offers a data feed, a bulk download, or a documented API. That sanctioned path is almost always cheaper than fighting the detection stack, and it will not vanish on you next week. If the terms of service say do not, then do not, because no clever handshake changes what you agreed to. For anything ambiguous, a short message to the site owner is worth more than a week of tuning your client, because permission turns the whole adversarial framing off. The compliant operator treats the site as a counterparty, not a target. The honest limits. I want to be straight about the boundaries here. None of this makes anything undetectable, and I would not trust anyone who tells you it does. Detection keeps improving. The labels get sharper, and what passes quietly today can be flagged tomorrow. A clean network and honest behavior are not a trick that beats the wall. They are just the absence of the contradictions that get you caught. And the moment your collection touches private data, or ignores what the site clearly asked you not to do, you have left the compliant lane entirely, whatever your tooling looks like. The durable version of this work is the boring version. Public data, honest identification, a gentle pace, and the rules respected. I run this infrastructure in production myself. Real proxy farms and real scraping pipelines. So everything I just walked through is the stuff I actually deal with, not theory. If you want to go deeper, the full written guides and the tools I genuinely use and test are at dataresearchtools.com. That is where I break down the frameworks, the proxy setups, the scraping APIs, and the honest reviews, with no undetectable promises and no guaranteed results, because that is not a thing anyone can honestly sell you. So to recap, sites judge the network you arrive on, the handshake and headers you send, what your browser reveals when it runs their code, and the rhythm of your behavior over time, and every one of those checks is really hunting for contradictions. The way to stay clean is not to hide better, it is to have nothing to hide. Respect the robots file, take only public data, identify yourself honestly, and move at the pace the site can carry. Build it that way and it keeps running. Subscribe for a new scraping infrastructure breakdown, and I'll see you in the next one.